Well, good afternoon, everybody. My name's Troy Raska from Pure Air Control Services, and I want to welcome everybody today to our online workshop series, Optimizing In-Room Air Quality, Best Practices for Air Purification. So I see we're right at the 2 o'clock hour, and I do see people are still filtering in, so why don't we go ahead and give them just maybe another minute to come on into the room, and then we'll begin. Thank you.
So as we kind of know here, we've gone over kind of high profile, like Mike, thank you for kind of outlining like the importance and how these kind of play into this, the need in room. So the localized HEPA air filtration, as we're kind of saying here, it's definitely a critical component, part of that holistic ventilation strategy for a shared space. But if we're taking into consideration the larger solution, right, and what can be, what can be done in that area, if we're talking about addressing the specific, issue, whether you're in a lobby, right, a high traffic lobby area, or if just shared meeting spaces, there needs to be something there to kind of address, the needs of those different kinds of environments. Why don't you, Troy, kind of explain a little bit more about what you're thinking in that question there, so that I can kind of.
Sure. And that's absolutely right, is that each space within a building is different and might have different needs or might see different uses even. And so, yeah, that need is critical to supplement those spaces with this type of technology. And so what we're seeing here is that we're seeing sort of the expert opinion and guidance, the engineering perspective of this type of equipment, and then the research all sort of coalesce and come together to back up the role or need for this. And so, and we're going to get into that guidance here in the next few slides, but yes, the experts agree that it's a critical component, and it also supplements larger initiatives in multiple areas, as we showed earlier, to really help at the room level. It's also a valid engineering control at the facility level, right? And what this means is that the facility management team is in control of this, okay? Again, we're talking about a localized air purification system in a commercial environment. So this isn't as much of a personal residential situation as it is an actual piece of engineered equipment that's going into the building to help with the solution. And as such, there's no input, there's no control from the occupants on their end. It's basically set it and forget it. It's a commercial grade product that you're looking for that is going to fit this need. And then, of course, the peer-reviewed research that validates and supports the need for this, which is, what we're going to get into right now. So there's a lot of prevailing guidance on this. As a matter of fact, as Mike alluded to earlier, there's been, so much confusion, and it seems like the science has been changing daily for the last year on everything from fomite surfaces, or how long does it last on a surface, or if you can be infected from a surface, to cleaning protocols, to, as Mike said, social distancing. Is it 6? Is it 60 feet? But one thing has remained clear and has even come into sharper focus, and that is that this is an airborne vector, or it's transmitted via airborne particles. And that means that to clean the shared or occupied space, we have to look at ventilation and filtration. And so this is where all of the experts come together and agree, and this happens in various categories. And I know that we have a lot of different folks on today from a lot of different backgrounds, everybody from engineers to procurement or purchasing people, and then facility managers and building owners in between. So we're going to try to keep this pretty simple, but still explain what a lot of this guidance is saying. So the Harvard T.H. Chan School of Public Health, and you might recognize that name from their cognitive effects studies that were coming out quite a few years ago now, maybe 3 or 4 years ago. But they're involved in all areas of building health. And they said as part of their guidance for reopening schools that improving indoor air quality in the classroom, they're looking at various, again, control strategies, ventilation, filtration, supplemental air cleaning like we're talking about today, and they're looking for 4 to 6 air changes per hour. And that would be for classrooms, and that would be with a combination of these approaches. And so really, if you look at this table, the triangle here on the left-hand side of the screen, and this follows a lot of the other guidance with ASHRAE and CDC that we're going to talk about in depth, but you're going to want to increase that ventilation rate, and that could be bringing in outside air, that could be increasing the air changes per hour. You're going to want to increase your filter efficiency where you can. We talked about that before and in previous workshops. If your HVAC system, your air handler unit is not rated for MERV, you cannot put MERV in it because it will damage the equipment. I mean, it's just that simple. So you're going to have to, do your homework there. And then, of course, at the bottom end of this funnel is supplement both of those points with portable air cleaners. And I do think that, ASHRAE definitely backs that up. Again, no surprise here, and that is, the CDC itself is saying consider portable air cleaners that use high efficiency particulate air, HEPA filters, to enhance your air cleaning wherever possible. And again, this was even really, if you look at this, sort of in the early guidance from the CDC during the pandemic. And so just, it's so very important. This is from 2019.
Yeah, Troy, and just
go ahead.
One point to that, is that, we'd spoken earlier here about how these guidelines, in pertaining to, this pandemic, and there's been kind of like these changes over time with how to kind of, kind of mitigate risk in that. But I want to kind of just bring the point that guidance around filtration is a very consistent space where we have Harvard in alignment with the CDC, in alignment with ASHRAE, right? This isn't something that we're seeing that kind of whiplash effect that we see with some of the other, as more research is kind of gathered, they can kind of hone in on, so we're seeing a lot of changes in some, but filtration is one of the areas where this has been a very steady, you have a consensus amongst the, the scientific and the regulating bodies where, this is something that you can kind of count on in the long term as part of your strategy.
That's absolutely correct. I mean, filtration is foundational to good indoor air quality, and not only filtration, again, on the HVAC equipment, but the filtration at this room level equipment as well, and then of course maintaining those filters, right, and being able to keep an eye on them, make sure you're changing them regularly, make sure they're tight in the equipment so that there's no bypass around them. So all of these things are so important, and you're absolutely right, Peter, that everybody is in agreement on filtration as long as it's done right. As I was saying earlier, you just can't throw a MERV 13 filter in a system that can't handle it, or else you're in for larger problems down the road. But when we get to ASHRAE, which is the leading body that is making recommendations for the HVAC engineering community and beyond, they've been very consistent in this as well. And of course, from their larger documentation, technical resources on filtration and disinfection, somewhat in general, and these are in quotes because this was verbatim copied from their guidance. It says add portable room air cleaners with HEPA or high MERV filters with due consideration to the clean air delivery rate and, or air exchanges, per hour air change rate. And then more recently, ASHRAE has done a very good job of updating their website, making it specific for certain kind of building use and certain kind of building scenarios. But they released sort of an executive summary or overarching guidance that is this PDF here that I'm referencing, Guidance for Reopening Buildings. And in it, and we're going to look at two very distinct categories where they talk about this. They have about 8 pillars of recommendations or categories of recommendations for reopening buildings or keeping your buildings open during pandemic conditions. And of course, the one I have highlighted here is combine outside air ventilation with the higher designed filters, but combine that with HEPA air cleaners to exceed the minimum ventilation and filtration requirements. So ASHRAE themselves are saying, hey, you have to do, X and Y, which is going to be the minimum. But if you want to back that up and exceed it, then you need to do Z, which is this localized solution, or add the additional HEPA air cleaners to really make sure that you are staying on top of managing those risks in the built environment. And then, of course, another big thing that ASHRAE has talked about is what's called flushing. And so our mechanical engineers and facility folks are going to know about this. But basically, what ASHRAE is recommending here is that you, when the building is not occupied, you remove all of the air within the building to the rate to achieve 3 air changes of outdoor air. So you're literally flushing the building. You could almost think of it as like having a blood transfusion. If your blood was bad and you're taking all your old blood out and you're putting all the new blood in. And so ASHRAE is recommending that this is being done once a day to remove what's called bioburden or biological pollution from the building. So it's making these recommendations and saying, or the equivalent, using HEPA particulate filtration and air cleaners. And that could mean a variety of things depending on the size of your building and how it's being used. And it could mean everything from sort of a portable HEPA filter or system that would supplement your existing HVAC system, or as we have said, some buildings up in the northeast of the United States and the northern mid-Atlantic don't even have centralized HVAC. They rely on opening their windows in the summer and maybe radiator heat, in the fall and winter. And so, there's options to flush the entire building out with this trailer device that, Pure Air Controls can offer guidance on that, or just opening the windows, or what we're talking about today, which is a localized engineered solution that is fit into each room. So really, when we start drilling down into this localized air purification solution, what are the best practices when we start looking at this at the facility level, at looking at trying to get the right technology fit to your needs? And the first thing that we want to consider, and we've seen plenty of this now with the pandemic, is that a lot of times if your organization is going out to a request for quotes or RFP, request for proposal, that the vague is very generic. It's not specific enough. It might just say, I need 200 air cleaners, and that's that. And when you do that kind of RFP or RFQ, you're going to get everything from a very small bread basket to a shipping container, as far as prices and technologies and different kinds of quality of devices. So you're not always getting the best value or the best solution in many cases. and you might end up with an inferior type of product, or a product that isn't even sufficient enough to take care of the square footage in the rooms you're putting them in and such. So, you know, Mike, why don't you take us through, what would be some considerations here as we're looking towards the best practices when thinking about writing a spec to procure this kind of equipment?
Yeah, absolutely. I'd love to. So I think, first of all, just to kind of draw on some of the points that you made earlier as well, Troy, I think that there's this concept or misunderstanding that these localized solutions are just temporary, or something that you kind of throw into the corner of a room and it'll serve a purpose for a short period of time. And I think if there's hopefully one thing that comes out of this pandemic situation, is that this isn't just a spot problem that we're trying to solve for. We're really trying to address indoor air quality in a proactive, ongoing way, and really future-proofing our facilities. And I think the other point from a few slides ago that I just add to is, this idea that the code and the regulations for what a building needs are really there to say, okay, this is the bare minimum that you need to do in order for that building to be occupied. And this pandemic has clearly taught us that the bare minimum is quite simply not good enough. Like it's not good enough. And that's why we spent so much of our time outside of these shared facilities debating when is a good time, when is a safe time for us to go back into these environments. So when thinking about a localized solution, a lot of this guidance when we think about best practice is really geared towards not thinking about this as just a quick fix that you're going to use for a few weeks, like a temporary air conditioning unit if your system air conditioning unit is out. So I think the first thing that we've got on the list here is really around automation and monitoring. The last thing you want is something that someone in the facility or someone in the room has got to be constantly changing, adjusting the settings, switching off on a nighttime, switching on in a morning time, because the thing that you're depending on there is, first of all, compliance, people actually doing what you're asking them to do. And secondly, people to even understand when they need it. Like, when do you need this to be running on a higher speed? When do you need it to be running on standby mode? So that idea of automation is key, and monitoring is something that just enables the system to give that feedback into the environment, whether that's for the occupant of the space or for the facilities and operations team in the building as well. Effectiveness, efficacy, some proof behind what the system is doing is key. So really make sure you address that in the way that you document the need. It's some form of additional air cleaning technology. So I think the baseline is really filtration. I think a lot of the guidance during this pandemic has pointed towards that. I think the slides that you just walked us through from the CDC, from ASHRAE, from Harvard, all point towards filtration really being the workhorse. But what other supplementary cleaning technologies can really boost that and add to it? I think not just going towards the cheapest possible solution, and I think that's where the concept of commercial grade comes into play. Is this from a reliable brand? Does this come with a reputable warranty period? Do you know that the organization is going to be here 2-3 years down the line when maybe you have an issue, or making sure that you can get the filters and the service for years to come? Because I think it's fair to say that whilst there's a lot of credible players out there today, there's also a lot of opportunistic players in the market that have seen the need and seen the demand and entered into this space. And then finally, you don't want this to be a hazard or something that gets in the way of people, or people move out of the way because it's an obstacle in the room. So that ability for it to actually become part of the facilities approach, and even though it's localized, that doesn't mean to say it's not part of the building. So just being able to get up on the wall and out of the way is another key way that you can really make it feel integrated into the environment.
Yeah, absolutely. And continuing that thought, when we talk about like a multi-stage filter system, and obviously looking at the guidance that is all in agreement, HEPA plays a large role in that. But what about having other filters working in tandem with the HEPA to take care of the other things and to make sure that the HEPA is even made more efficient? Again, we look at that facility integration and being able to have different sizes for different square footages. So the ability to service, a standard larger size room all the way down to a smaller, type waiting room or maybe the nurse's room in a school, which typically isn't a very big space. As Mike said, maybe additional important technologies that would be included, like these air cleaning enhancements, bipolar ionization, UV, etc. The smart automation and monitoring, having that onboard operational display, as we talked about earlier, having a localized solution gives folks, teachers, staff, your employees. We know there's low worker confidence right now from a series of polls that have gone out from Honeywell to Robert Half, where 68–70% of workers don't feel confident coming back in their building. So having an operational display is so important. And then just quiet operations, so it's not disrupting folks when they come back in to the workplace or a classroom, for example, because we know that sound plays a very big role in things like LEED and well building certification, as far as the ergonomics or the environmental quality of an indoor space. So this just dives deeper into what we were just talking about. But when we look at effective multi-stage filtration, we're talking about one or more filters, aren't we, Mike? And why don't you walk us through this type of solution, as it relates to the Fellows air purifiers?
Yeah, absolutely. So we do take a multi-stage filtration process. Definitely at the center of this process is the HEPA filter. We've spent some time talking about that, but we also bookend the process with some additional filter steps. So the first part is a basic pre-filter. I say basic in the sense of the way that it looks and feels, but the role that this filter plays is still key. It's really there to protect and prolong the life of the other filters in the process, and really to take some of that particulate matter out of the process before the carbon filter comes into play. Stage 2 for us is the active carbon filter. So we use granular carbon, a good weight of granular carbon as well in our system, just to make sure that you've got that right amount of lifespan to this. This has that natural ability to absorb the odors and the volatile organic compounds from the air. Then comes our true HEPA filter. So true HEPA, meaning that these are graded to achieve 99.97% filtration effectiveness at the designated size of 0.3 microns. But just to address a common myth when it comes to micron sizes, a HEPA filter doesn't stop working like a sieve or a colander at the size of 0.3 micron. And actually, when we get to even smaller micron particle sizes, that HEPA efficiency actually increases again because of the Brownian motion. So it's just the laws of physics that define that 0.3 micron particle size as one of the more difficult particle sizes to address. And then finally, we use what we call our plasma true technology, which is a bipolar ionizer, really as a complementary cleaning method to further boost and enhance that physical capture process as part of the system.
Yeah, I think. Oh, go ahead, Peter.
Yeah, I just wanted to say that, Building Health Check, my company, we work very closely with laboratories to do research for devices before we decide to back those devices. And one of the things that was really appealing about the Fellows air purifying solutions was the balanced nature of those builds, right? It was, we've researched, dozens and dozens of purifiers and air purification technologies, and it's really interesting to see, like was referenced earlier, just that opportunistic nature of some of these products that have come into the space. There's one product that we're working with our lab partners with right now to observe, and it has already started to self-destruct due to its unbalanced implementation of one of these filtration enhancements, right? And so it's already deteriorating its own materials, and we've saw this occur in under 5 days' time, right? And it's kind of concerning because this is a product that a school system actually chose as their winning bid recently, within the past month. So these are kinds of things we like to, here at Building Health Check, we work with our lab partners. We do studies on these devices that we see rising above a certain level of notability. And, this is why we've made the decision to go with these solutions. It's balanced, it's longevity, it's been researched. This is these are just some points that need to be kind of weighed when our procurement partners out there and our facilities people out there that are kind of part of this take into consideration that this shouldn't be something that is made on a whim. A decision like this isn't something that should be made on a whim. There is research, there are professional facilities out here that are monitoring this kind of thing, and it's important to kind of get their feedback and not just go with the person, on a whim of a decision.
No, that's absolutely correct. Is it properly engineered? Is it durable and rugged? So it can withstand, a facility, and so that it's built to last. Especially, just like Mike said, do you know that this company that's been around 100 years is going to be around 100 more, right? So I think all of those should factor in when you're looking at best practices for the type of equipment that you're going to source for your buildings. Absolutely. When we look beyond the filtration of these kind of portable or localized air cleaning solutions, we also bring up the topic, and Peter was just actually talking about it, about air cleaning enhancements. And this could be, anything from, UV light to UV germicidal, to different types of bipolar ionization. And as the example of the one air purifier that was recently tested, one of these technologies was deteriorating the interior components of the actual device and pretty rapidly. So again, but it's still good to have them if they're in the right engineered solution, right? So we look at,
it's still good to have something that works when it's engineered to do it properly, right? It's not bad by default. That's what should be said. It's bad when it's implemented poorly, right?
Yeah, that's correct. And so how does, like, for example, would bipolar ionization, or cold plasma technology, play into this device, Peter?
Sure. So ionization, the true plasma technology that's built into the Bellows air purifiers, it's done in a way that it is boosting the efficacy of the HEPA system, right? So it is being, it's being emitted as part of the airflow, the clean air that's being put out into that space, and then the balanced number of ions that are being, oxygen ions that are being released, they are, positively and negatively charged, and due to that charge, these ions are naturally drawn towards contaminants of the opposite pole, right? And so it helps in what's called clustering, right? So there's particulate in the air, whether it be 2.5 or smaller, and they, just by nature, these particles are positively and negatively charged. And so the balanced emission of oxygen ions are released through the true plasma technology, and they seek out these contaminants. And when they join to them, it's similar to how a snowflake is formed up in the upper atmosphere, right? You have the drawing in of other water molecules that happens up in that upper atmosphere. And a similar thing occurs here where the positively and negatively charged ions are trying to balance one another out. And so therefore, when they kind of join with these contaminants, it could be pollen, it could be viral, it can be skin cells, whatever is floating in your air, and it causes them to be pulled together. And so this compounds the effectiveness of the filtration system, because now you may have been dealing with a particle of a very small size, and now since you've kind of enacted this kind of clumping technology, now it's kind of making these contaminants more easy for the filtration to pull these out of your air supply and prevent them from being recirculated.
Which in turn extends filter life. So again, when we're looking at this kind of localized solution, it's always good to see what kind of supplemental technology it has, do the due diligence and research, and then really see if it's going to actually aid the air cleaner itself. Again, when we were looking at and going through these best practices, Mike, we were talking about smart automation and monitoring, and I think there's two key areas that we want to talk about, and that is, well, automation first and foremost, and then monitoring. So what does this automation look like? What do we expect in one of these smart devices?
Yeah, no, great question. So as we were looking at those best practices throughout the development of the commercial Fellows Air Purifier system, one thing that we acknowledged was there's really two primary drivers that we believe a system should be responding to, and a lot of the guidance out there supports that. One of which is actual measurable indoor air quality parameters. So for that, we focus on PM 2.5 and VOCs or odors. So we want to be able to address and monitor those. But then the second component is just human activity, occupancy. And I think, again, coming back to what we've learned from this pandemic, we can't necessarily detect instantly that there's a COVID transmission taking place within a space, but we do know when there's 30 children running into a classroom, or when there's 6 people walking into a conference room. So what our system is doing is it's constantly monitoring PM 2.5 and VOC levels, but also monitoring occupancy levels through a sound and a motion sensor. And we're the only system through patent protected technology that can combine all of these sensor feedbacks and automatically respond based on not only air quality levels, but also occupancy levels as well. And based on the mode selected, the machine will work harder based on higher occupancy levels, higher noise levels, or a detected air quality problem. But also because of this, let's say it's an office environment and the office is out of action for the weekend, come Friday night when air quality levels are good and occupancy levels are good, the system will go into standby mode, preserving filter life, preserving energy, reducing operating costs. Monday morning, 5 a.m, when the team comes back into the office or the facilities team start to fire things up, that system will automatically acknowledge that that building is back in action and start doing its job again. So for us, that's what the automation side is all about. And then from a monitoring perspective, I think the next slide gets into the detail here. So what we take all of this information and we give this feedback in real time on a screen right on the front of the unit. So this is what we call our PureView technology, again, patent pending technology. And there's a couple of different options here. The first one, which we see on the screen now, is just a simple definition of the current room status, the air quality status. And for this, we either say clean or cleaning. So the idea here is that we don't want to use a negative word. We don't want to be using red flashing lights and saying pour, evacuate. That's not the case, but we just want to give that feedback of this is actively doing something. It's detected a problem and it's working a little bit harder in order to deal with the situation, or indeed it'll just say clean because it's done its job and the room is being maintained at a good air quality level. And because we're using air quality sensors on the air intake and on the outlet, we're able to actually show the real-time delta between air in and air out, which is what the 99% rating is there. The other option is you can actually see real-time PM 2.5 levels as the air is entering and exiting the machine. And our definition of clean or moderate or poor on those screens is directly linked to the standards that you see from the EPA, the IAQA, reset well, those types of certification schemes as well. So this is really about providing that data where needed for the facilities team, but also providing that peace of mind to the people that are actually using the space.
Yeah, excellent. I mean, I think those are all, good points to make that, is this machine energy efficient? Is it smart to be able to recognize occupancy and really kick in when it needs to? And then, again, that peace of mind, not only for occupants, but, the facility manager to be able to run through the screen and see that it's working or see that it might need a filter change. So it would have that reminder as well. I think, and folks, we're getting near the end, so we appreciate you all hanging on with us. We're about to wrap it up and take your questions. But I do think that this particular component for best practices is so important, right? Is that what we've noticed going into buildings and testing buildings throughout this pandemic, we've never been inactive. We've been in the office and out in your buildings working and testing the environment. And so oftentimes we see facilities take, a one size fits all approach and, going with maybe a personal, what we might call a personal or a small residential air purifying unit and stick it on the corner of the desk or on a bookshelf or a serving table in the conference room and say, okay, we're done, we're purifying the air. And quite frankly, that little device is overworked, cannot handle cleaning the entire room, based on its size and its motor and its fans and its filtration. So it really isn't an engineered solution for that occupied space. I think another thing to note here is that at least from the pure air control side and even building health check, is when we're coming alongside of a facility and we're doing environmental consulting, we know where in the room to put these air purifiers. We engineer it in conjunction with the mechanical output, so where is the supply air duct, where is the return air duct. We want to put this type of machine in the optimal place within the room to be able to supplement what's happening with the normal HVAC system, heating, ventilation, and air conditioning system. So I think you take that into consideration, but it's so important to have different sizes of equipment for different size rooms. And I think that when you're looking at this, it's pretty key that we can provide solutions to pretty big classrooms, conference rooms, right down to a small bathroom. Right. And I also think, Mike, if I'm not mistaken, when we're talking about this automation of the system and sensing occupancy, that's when these air purifiers will kick in and be able to provide these 3 to 5 air changes an hour, depending on what it's sensing the load in the room to be. Is that correct?
Yeah, that's right. Yeah, so the ranges that we do are based on the machine monitoring that situation and responding to it instantly. And I think that occupancy detection is all about not waiting for the problem to be in the air, but about making a proactive decision to increase those airflows. And if we think back to right at the start of today's webinar, that guidance from Harvard at really aiming for that 4 to 6 air change level through a combined holistic air quality strategy, which is ultimately a combination of a ventilation plan with localized filtration as part of that. So our system can get to that 3 to 5 level of air change within these ranges of square footage. But if you boost that, if you use that alongside your HVAC air change level of 2, 3, 4 air changes, then you'll get into some really strong levels of air changes. And Harvard certainly wouldn't say, hey, stop at 6. They're just being realistic with their guidance and trying to address what's feasible. But no one's going to penalize you for being at 7 or 8, believe me, and your occupants will thank you for being at even better air change levels. So yeah, the range that we provide here, right from the right hand side of the slide, is our smaller unit, ideal for those small, more kind of personal 2-3 occupant spaces. And then moving into the middle, this is where you get into more of those significant shared spaces, conference rooms, meeting rooms, some smaller classroom environments, and then the larger unit on the left-hand side is really geared towards those more bigger open plan spaces. And of course, you can combine multiple units to address a larger open plan space as well.
Yeah, that's also good information to have. And so when we look at these different sized units, we're also talking about, again, commercial grade, rugged durability, and the ability to integrate into their facility surroundings. And so, Peter, why don't you talk about a few of these options that are available on these type of devices?
Sure. So I just want to preface this slide with a little anecdote that one of my clients out of the Boston area had told me after they had completed their installation in their restroom facilities. He said, the employees joke around now that if you want to get a breath of fresh air, you go into the bathrooms, because they've been so impressed with how these things have been working. So, so the good thing about the systems is that they come in a number of configurations. And we have the ADA compliant wall mount recessed configuration here on the right-hand slide there, or photo on the right. And then you have the, if you need a higher level of filtration, then we're able to upgrade there to the wall mount 3, the Professional 3 series there. And that's good because it gets it up out of the way. This makes it like, you know, like a dependable part of your facility, right? This isn't something that's going to get kicked around. We know that we're going to need this area covered for the lifespan of the facility, right? And we need something with a long warranty. That's something that we can count on for years and years to come. And so, you know, the wall mount configuration of the Pro 3 is a great solution for that kind of need. If you are in a facility where you are, you know, needing a more portable, a more like spot kind of solution, if like, let's say your building is on low occupancy right now and you need something kind of just to follow your staff around, then the, you know, the portable solution on a stand there, it's shown on the far left-hand side there on the floor stand configuration, then that's an option that's been pretty popular as well. We've seen, personally, I've seen, and a lot of my clients have been utilizing the wall mount and some of the, in the education and let me say the commercial office space, right? Those are both, they're looking for that wall mount configuration of generally the higher capacity 3 and 4 units. That's what I'm seeing as being, because it checks off the boxes and it, you know, it has the motion detection, it's proactive in its solution, it's a long-term, it has a 5-year warranty. It just, the checks goes off. And from a procurement perspective and facilities perspective, they're looking, what can I do to solve this problem that I'm not going to have to keep coming back and fixing this thing or putting more man hours on, you know, like what's the easy thing that has longevity, that's cost effective and does what I need it to do, right? And so that's where we're coming to, that wall mount has been, you know, the one that people are going to.
Yeah, absolutely. And one thing is, if you can see in some of these pictures in the past slides, is that there's a key in access to the filtration. So it's essentially tamper-proof, so that occupants can't mess with it and pull the filters out. Another good thing about the recessed unit here and the wall-mounted unit is that it's hardwired into the building's electric, so the plug can't be unplugged or tripped over or kicked out of the socket. So again, for that continuous autonomous operation. So, you know, as we're drawing to a conclusion here, and again, thanks everyone for hanging on. We have nearly everybody for almost an hour now, so I do appreciate that. As we're drawing, you know, to a conclusion here, and we've gone through all of the regulatory and associative bodies that have set this type of technology into their guidance and recommendations on the forefront. Let's spend a few more minutes here at the end, and then we'll get to your questions. I see a few popping up, but let's spend a few minutes here talking about, you know, what are we doing as, you know, corporate socially responsible entities for the efficacy testing of these kind of products, and specifically these Aeromax professional air purifiers. I know, Mike, you guys were heavily involved with some coronavirus testing recently that came out. So why don't you take us through this slide pretty quickly?
Yeah, sure, absolutely. So, you know, we like we've talked about, you know, our HEPA filtration is fully compliant with that HEPA standard. That's well known and well publicized. But what we wanted to do is actually address the current topic of airborne coronavirus and put the machine up to the test against that. Back in 2015, we did do a lab test for airborne H1N1 or influenza A. We're able to demonstrate 99.9% removal after a 35-minute period. So we want to do something similar with not with the actual SARS-CoV-2 virus. It's not possible to utilize that right now in a large open plan test chamber environment, but we were able to use the surrogate coronavirus, human coronavirus 229E, aerosol, work with an independent laboratory to aerosolize that within a 20 cubic meter or approximately 700 cubic foot test chamber, And after 20 minutes, we were above 95% removal. After 40 minutes, above 99% removal. And after a 1 hour period, achieving that total removal of 99.99% within that environment. So something that we knew, quite honestly, that we would achieve these results. I think all the data and the expert opinion has pointed towards this filtration. We knew it was going to be effective, but there's still a lot of questions out there from the marketplace. So we just wanted to put some of those conversations to bed and really put our unit to the test and back up some of our efficacy statements.
And Mike, I see it mentioned here in working with fellows and thank you to Fellows Air Purifiers for coming on as a guest today. And sharing this good information with us. But the methodology and these reports are available upon request. Is that correct?
Correct, yeah. And some of those are readily accessible online. And then if more information is needed, we're always more than happy to provide that as well.
I mean, folks, we could spend an entire hour just on efficacy testing, and I'm not going to belabor this very much. But as Peter alluded to earlier, Building Health Check LLC is a sister company to Pure Air Control Services. Pure Air Control Services, we're a professional services contractor. And so as such, we come alongside, we consult, we provide services such as a reselling service of some of this equipment and other types of equipment. And then we will go ahead and install it and service it down the road. But as part of Pure Air Control Services, we have a fully accredited laboratory on site at our headquarters. And this laboratory has its own environmental test chamber. So we do a variety of product efficacy testing where we can do these very similar tests that Mike was just talking about. We did not do the coronavirus tests for fellows, so in effort of transparency there. But we can simulate a variety of conditions. We can inoculate it with a variety of contaminants, particulates, mold, bacteria. And as such, we've tested many IAQ products over the years, since probably the mid-2000s when we put this into play. In this picture, you can see at present, and this is still set up back in the test chamber area, we're testing a very big piece of air conditioning equipment for a third party person. But in 2016, as Peter said at the beginning of the presentation, we did do a study on the AirMax Pro because we were considering it, or I should say Building Health Check was considering bringing this on as an integral part of their product line. And so, yeah, we observed, within 27 minutes, a 98% reduction of 0.3 micron airborne particulate. And of course, we studied other sizes of airborne particulate. And again, we could almost do a whole presentation just on what goes into this kind of study, but it just kind of gives you a feel for what we're doing. And many of these things on the Pure Air and ED Lab, environmental diagnostics laboratory side, we'll conduct our own studies because we want to be confident in what we're recommending to people. And then of course, it is a paid laboratory service, so we're under non-disclosure agreements all the time from various third-party manufacturers that are coming to us to test the efficacy of their products. And so through this pandemic, we've definitely seen an uptick in production out of this test chamber, and we're privy to a lot of information, unfortunately, which we can't discuss in detail or name. So everyone, we're right at the 3 o'clock hour. We certainly appreciate you hanging in there with us. And we do have a few questions from folks. I'll go right through this. Again, we've been around since 1984. We have these 3 specialized divisions. This is Pure Air Control Services I'm talking about. And all told, we've done 700 million plus square feet in over 15,000 buildings. And so we have all of the industry standard certifications and affiliations, for each of these divisions that are required for us to work in your buildings, not the least of which is that our laboratory is CDC Elite Program certified, A2LA accredited, and New York State Department of Health certified. And also Pure Air Control Services is a certified environmentally responsible contractor. So when we're in your buildings working and doing remediation work, we're doing it at the very highest levels possible. So again, on behalf of my guests, Peter and Mike, I thank you. Here's our contact information. Again, we will send you guys the replay link of this webinar so you can share it or review certain parts of it. The slide deck is available in your handout tray. And you know, stay tuned down the road. We're doing about one of these a month, and always fresh and current information. So listen, let's get to some questions here. And I have one of the folks that was on today. And this is a very interesting question. I think, Peter, you could probably jump in right on it, and then Mike could maybe support it where it's specific to Aramax. But we have Stephen York who's asking, so are these localized devices available for school buses?
Yeah, so that is a really great question. So there are a number of solutions for school buses, also for public transportation, subway type environments and airplane type environments that have come into kind of the forefront recently. The school buses were a big concern early on in the pandemic, especially up north in Canada and in the northern US, because the weather makes it kind of prohibitive to be able to kind of have that ventilation that you're able to have down south. But these specific systems are not tailor-made for school bus environment, but there are other solutions that we can help you with in that regard. The Aramax is a highly diverse system that can be utilized in a number of building environments, but it's not specifically made for a vehicle environment.
Is that fair to say, Mike? I would think
Yeah.
is
Yeah,
primarily because of a power requirement. Is that right?
Yeah, that's true, and I think it also comes down to, you know, the building code that you're recognizing in the development of these products. So, you know, we fall under UL 867, and so that there can be limitations or at least specifics to address in the development of these from an engineering standpoint, and then also voltage requirements as well. The one exception is we have worked with a number of blood donor buses, where because then the systems are in use when the vehicle is static, so it's not technically it's not technically transportation while the purification is taking place. But of course, those are becoming static environments. They're almost becoming temporary facilities. But it was obviously critical that blood donation didn't stop during the pandemic, and we were super grateful to be able to work with those as an example of that sort of transportation method. But yeah, it's not something that we currently address with this range today.
Yeah, one quick note to that is, you know, the regulation that goes into anything that goes into a school bus is a completely different thing than what goes into a building. So the materials, the construction, the mounting procedure, everything is a completely different set of regulation.
I gotcha. Well, that was a very interesting question, and I actually just learned a little bit about that I didn't know. So thank you, guys. Hey, listen, we have another question, and that's from Eric Johansson, and he's asking, what are the power requirements for these three devices, voltage and hookup and stuff?
Sure. Yeah, I can address that. So there's no sort of industrial power supply requirements. These are pretty low load in terms of ampage and wattage. So it's standard 110 volt product, and typically the wall mount process just involves some form of wiring to be made available. That can either go through the back of the unit, or it can go through some sort of top-down or bottom-up approach into the system as well. Typical wattage on the lower fan speeds, you know, you're looking at 6, 7, 8 watts for the low fan speeds, up to a max of around 150 watts, but around the 2 amp level in terms of the actual loading as well. So very, very, very low load. Pretty simple, straightforward electrical installation process. And then because of that, the running expenses, you know, are extremely affordable as well. So it's not something that's going to add a significant increase to your electrical consumption.
Yeah, one note to that is, you know, had the question. So people kind of see the appearance of the Aramax Pro 4, and it kind of looks like a mini split air conditioning system. And so, you know, the question that I've gotten is, does this require a dedicated circuit, right? And the good news that is, at least I don't want to speak across, you know, all codes, but you know, in most areas, a dedicated circuit is not needed. It can be installed as part of a general circuit in a building.
Yeah, correct. Yeah, it's always good to address, you know, local code requirements. I know they can differ quite significantly, but yeah, I would agree. I would agree with you, Peter, for sure.
Yeah, okay, well, listen, we want to be respectful of everyone's time, and we have well over half of our attendees still on with us right now. We did get a little bit late of a start, but again, I'd like to thank everybody for coming on today. If we didn't get to your question, then don't worry, it's logged into the webinar platform here, and we will go ahead and answer those directly by email one-on-one. After the webinar concludes, or as you're logging out, there'll be a short survey, and we would really appreciate it if you let us know how we did today, if there's anything that we could improve on. And then, of course, there's a few questions we threw in there about your facilities and what you've currently been doing to protect the IAQ in your environment during the COVID-19 pandemic. So again, folks, thanks for showing up. My name's Troy Raska, and on behalf of Peter Kelch and Mike Booth, thank you again.
Thanks, everyone.
Thank you, guys. Have a good one.